This video is called the multi-level firmament theory. It's based on work by Theodore Dr. Seuss Geisel in the Here's a Who movie or book, and also on the Queen album cover News of the World, which was designed by Frank Kelly Freas. And both of those artistic types of work combine into this theory that I'm taking from a non-scientific area and placing it in the scientific field. So how it goes is that atoms and are kind of like little solar heliocentric existences, and that you have photons and other little particles shooting around, and they really act a lot like comets. And then on the other length end of the spectrum of the firmament and of gravity and of what we look at from our frame is solid, liquid, and gaseous things. Then we have the Queen album, News of the World, where there's a night sky and then a much larger human-like creature busts through the sky and is reaching in towards the people in our size level. And that is the basics of how the theory came about. And I think there is like a bandwidth of this firmament, so that it's similar to a spectra in the light spectra. So then if you take the emission spectrum of a certain element, when you heat it or cool it, the electrons expand and go like right up to another level without any time, hardly any time. So as this happens, it gives you this spectra where there'll be a band of light here, and then like a red, and then a blue, and just certain places on the light spectra where light will show up, and in between there's no light or reflection or anything given off from these elements. And so what I believe is that at the atomic level, the energy makes things that are and appear to be solid, like a proton and a nucleus and a neutron and whatever in an atom appears to be a solid, a firmament, a surface, a membrane like separating one density to another density, and then there's the electron spinning around, and that is also like a solid materialistic thing. Though it's very small and hardly any weight, it is still solid. We've proven that now. And then it's the same. It appears to look the same as the planetary size system, because that the electron is not anywhere predictable in any which our planet. It's going around there. How are we going to predict where that's going to be if it was that small, like in an atom? We can't see it good enough over that amount of time, because it travels so much faster too. Like it takes a year for our planet to go around the sun. So that's a lot slower. So if it was a electron the whole history of the Earth and the Sun and everything would, you know, the amount of revolutions would probably take place in a fraction of a second. So then, who knows how the Earth spun around over billions of years and what track it made and how that it leaned and everything else. And then you can extend this up to the next level because then we have the planetary arrangement, and then that adds up to galaxies, and then galaxies, billions of galaxies, they could act like a solid or liquid or a gaseous on a much bigger and slower reference frame, relative to ours. So therefore, instead of like expanding from the Big Bang, a larger force or like a larger phenomena, something like Boyle's law and PV equals nRT or something, can be happening. And just because that happens in gases, if the sun shines or an external force comes on atoms in the atmosphere and in water, they get further apart and expand. And then, well, if the sun sets, and then the atoms get moved back closer together as they cool, and it's rather than having everything come from a central point, galaxies are like a sea in the size they are. We can, with what we see, even if like compared to an infinite universe, we can only see just a real small amount. We can see that it appears that galaxies are reasonably spaced. Some of them get closer, and they have little and intertwine and fall together, just like atoms do, and become a single galaxy. And some of them, like on atomic scale, there's nuclear reactions on heavy elements, and they break apart to smaller particles, and at the galaxies do a similar thing when they collide. And then there's a supernova. So a supernova, I imagine, would be very similar to an atomic reaction, giving off a ton of energy, and that's just the way the theory is. So, good day.